In this video, we're going to address the total cash flow per year, which is number 4 of the 4 items that we're completing in this process. On previous videos, we did the pro forma income statement, the capital requirements, average assets, and operating cash flow. Now we're going to use this information to move into total cash flows per year, present value, and future value of those cash flows. So we will start by filling out the operating cash flow that we already calculated here. These are the operating cash flows we calculated in our previous video. So we have that information for every year. Now let's talk about changes in net working capital. Now notice that it says changes in net working capital, not the actual net working capital required. This part is just asking for the net working capital cash flow direction, for example. So we do know that on year 0, we have a need of net working capital of 20,000. However, here we can express it as a cash flow. So that's cash going out in order to get the project started. So when it's a cash outflow, we represent them as a negative, cash that went out. Same thing with capital spending. This manufacturing equipment, which we also call net fixed assets, is also going to serve as the capital spending, money that we spent in equipment, capital assets, etc. So same thing, we need to represent this as the negative of the 90,000. You could have clicked to here, because it's the same thing in this case. And the total project cash flow for the period, all you do is you add those two together. I'm going to go ahead and go here, add them all 3. And the reason is because that's what's going to happen moving forward. There's no operating cash flow on year 0 because you haven't started, you're just about to get started. So that's how we get these numbers here. Now, what happens is this reflects that you do need the $20,000 every year, but that does not mean that you have to come up with an additional 20,000 every time. You recover that from your operations. So that 20,000 gets rolled over. So there is no other cash, assuming everything goes according to plan, there's no need to generate another $20,000. You worked your numbers, and the $20,000 that was initially laid out, after everything is said and done, it gets rolled over to the next year and gets rolled over to the next year. However, in the last year, when you shut down your operations because the project life is 3 years, you recover the 20,000. So now it's a positive because the $20,000 is going to come back in. So you have recovered the net working capital. And then all we do is we take same formula, adding all 3 items together for every year. And that is what the project cash flows look like year to year. All right. Now that we have that, the total cash flows for every year, we can talk about present value calculations. So for present value calculations, what we're doing is we're taking these cash flows that are in the future, year 1, year 2, and year 3, and discounting them to see what the number would be, their present value today. So future money, how much is it worth today? So we're just going to do it right under each one of them. And we are going to use the required return as the hurdle rate or the discount rate. Okay. It's your standard present value calculation. Nothing fancy. we take the amount that we want to do and we're going to divide it. We're going to divide it by 1, this is the discount portion, plus the discount rate. And it's going to be raised, or the exponent has to be how many periods. So one way to do it is to understand that I'm moving from year 1 to year 0, 1 period. I can take the 1 minus the 0, and that becomes my exponent to reflect 1 year. All right, let's go ahead and lock in that 0 there so it doesn't move. I'm going to lock in this number as well so it doesn't move. And the reason I do that is because then I can copy and paste the formula to make my life easier. And if I did everything correctly, if I copy it and paste it here, I should get the right calculation. And as you can see, I get the cash flow of year 2 divided by 1 plus the required return, which is our discount rate. And then for the exponent, I did 2 minus 0, representing 2 years. So that's the exponent. And the same thing happens in year 3. And the present value of that cash flow. Notice that we have the cash flow for the year divided by 1 plus the discount rate. And the exponent piece is the 3 minus 0 for 3 years total. Now what we do, this is the present value for each one of the cash flows. Now we want the total present value for the entire project as it is, just the present value of the future cash flows. Okay, so all we do is we add them. So I'm going to do sum. So our Excel function, include those 3. And all we did was really add them, this plus this plus this. So the present value of all these cash flows is $120,648.32. Now, because we're going to need future value for some of the calculations here, the modified internal return, for example, we're going to take this opportunity to now do the same thing we just did, but moving them in the future. Here, we moved them from future years into year 0. Here, we're going to move them from future years further into the future to year 3. So let's start with the first one. Very similar process, but instead of present value, we are going to be using the future value calculation. Okay. So we start with the cash flow of year 1 multiplied by 1 plus, remember this future value, multiplied by 1 plus, allow me 1 second, my screen is freezing. 1 plus the required return. I'm going to lock that one in so I can copy and paste later. And that's going to be to an exponent representing the periods in the future. Now, we're going to grab, in this case, that's where we want to go in the future, year 3. Going to lock that one in, minus the year I'm in. Now, this is the main reason why I do this 1 year minus the year I'm in, which I did in present value. While in present value, it didn't make much of a difference because we're always subtracted by 0. A common mistake in situations like this is that they see, oh, I'm going to year 3, so I'm going to raise it to the 3rd power. That would be incorrect because you are in year 1. So from year 1 to year 3, you're only moved 2 years in the future, not 3 years. So that's where this becomes useful to understand what the exponent should be. So we have a 74,563 and 63 cents as the future value from year 1 to year 3. Since I locked in some of the values that don't need to move, I can just do this, and it gives me the future value of this cash flow from year 2 to year 3. And once again, part of the key elements is that I did 3 minus 2, 1 period. Same thing, repeat the process. Now notice that the future value of this cash flow is the same. That's what's supposed to happen, because from year 3 to year 3, there is no growth in the future. So the formula still works where I did 3 minus 3. So the exponent is 0, pretty much making this a 1. And then that times 1 is the same number. So the formula works. And those are the future values of each one of these cash flows in year 3. Same as before, we're going to add these together to get the total future value of the project in year 3. So our sum of the future values of the cash flows given as the future value of the project in year 3, which on the next video we will use to solve some of these measures. That's it for this video. And on the next one, we'll move on to decision measures.